welcome this evening to this March branch talk on developing commercial abstraction layers for multi-client application. So before we hand over to tonight's speaker, just a few messages from me. Oh, that my screen froze. That was not very useful. So just some notes about behaviour during the meeting. Please have your microphone on mute and video off during the presentation. If you've got any questions, add them into the questions pane. If you don't have a questions pane, use the chat, and we will go through the questions at the end, possibly asking people to unmute and read out the questions themselves rather than just us reading them out. So be aware of others, be welcoming and respectful and understanding of people's differences, be friendly and patient, be open to all questions and viewpoints, and please be kind and considerate to others. Okay. So just a bit about the branch. So my name is Bev. I am the current chair of the Nottingham and Derby Branch, the BCS. If you want to find out some more information, you can go to our website, which has got the link on the screen. And I think, Pedro, if you could copy the link into the chat as well. So on there, you will see some information about the committee, although that still does need updating. Information about the AGM and upcoming and past events. So past events, you can find the links to the YouTube videos of our recorded events over the last couple of years. And you can also follow us on our LinkedIn group. If you search for BCS Nottingham and Derby, you'll be able to join us there. Okay. So for those of you who are not BCS members, you can currently get a 20% discount on your membership. If you use the code BCS NOTS20, that should apply the discount for you, and we would love to have you join us. And very finally, upcoming events. The next talk will be on the 17th of April by Taran Joseph on DevOps tools and their uses. Booking isn't quite open yet, so please do check on the website or on or LinkedIn for information, or if you follow the BCS on Eventbrite, you should be able to find all of our events on there. And very last thing before I hand over is, if you are sitting out there in the audience and you're thinking, I'd quite like to do a talk, then there's a link here for you to complete a form saying who you are, what you'd like to talk about, and we will contact you to hopefully be able to get that scheduled in. Okay, so that's all I have to say. So if I stop sharing now, and I will pass on to Jack.
Oh, perfect. Thank you very much. 1 second, let me just load it up.
It was a bit abrupt.
Yeah, 1 sec. Right, are we... Now I've lost the Zoom setup. Right, there we go. I can deal with that. Okay, so hi guys. My name's Jack. Who am I? I am a senior engineer at Magnopus. Magnopus specialise in XR and MetaVerse experiences to do with digital twins. I'm a senior programmer on the core tech team, which means that I am responsible for developing sort of key core libraries that are used across multiple clients within the company itself. A little bit of how I sort of came to here from sort of Nottingham Trent University. So I joined DevSoc, which is the Software Development Society at the university, in my second year, which got me into programming. And then I ended up, getting a placement working in hybrid mail, which is, long story short, is when you press print, it sends it off to a printing office, and you can basically print direct to mail, which, yeah, I didn't even know was a thing until I got that internship. And so, yeah, so that's that side. And then when I came back, I then joined the Robotics the robotics lab and did my final year project under Pedro, which was to do with sort of the semi-fire wildfire prevention project, which was identifying the height, width, and canopy density of trees, and also using the NDVI index to check the health of those trees. And then from that, I ended up getting into sort of FPGA development, because the board that I was using to do this AI inference was a Xilinx FPGA board. And then from there, I ended up working in sort of FPGA to C++ abstractions. So that was creating C++ libraries for companies that wanted to utilize FPGAs but didn't want to have to have a full-time FPGA programmer on their team. They wanted to just be able to create basically a scenario with the FPGA that then they could sort of access and take advantage to as and when they needed to. And then, yeah, so I started doing abstractions during my time with FPGAs, which then moved me on to medical. So that was to do with endoscopic cameras, so like keyhole surgery. That was passing through the data from those and then projecting that onto sort of multiple screens at high frequency, 60 frames a second, sort of 10 to 15 screens all running at once. That was using a card to host system. So that was FPGA to PCIe through to a GPU on the outside. So the GPU is what connected the screens to the monitors. The monitor to the screens. And then sort of after that, I've ended up where I am now, which is sort of a low-level template engine development, which works in the pretense of having sort of multiple clients, multiple internal clients. We have Magnopus have multiple sort of web, they have web clients for their systems. They have like game engine clients, so sort of multiple different ones, multiple different languages. Currently, we service such ones as like Python, Swift for iPhone. We also have Java. We have JavaScript, and sort of multiple different sort of languages, but it's all based off our C++ code. So day to day, I write code in C++, and then we abstract that into multiple sort of languages. But what that means is that everyone has their core, basically their core endpoint is what we develop. So it lowers the risk of bugs, etc., etc. So yeah, that's sort of a little bit about me. And so yeah, we'll go on to the next slide. So what defines sort of an abstraction layer? So the number one sort of thing is, I would say, is it being well defined. So it's making sure that when you're writing an abstraction layer, who your sort of end client is going to be, whether that be internal or external. So when you have sort of this layer, you're looking to make sure that will the functionality and the way that you want to implement this, will this work for multiple code types and sort of multiple sort of scenarios. For example, there's no point using sort of the on method, so like the on click, the on the on upload in sort of C++, where you would have a generic callback attached to a reference, whereas that is very common. That is a very common way of using it in JavaScript. So you have to find a way to get that to work in both, and then that's where the templating engine comes in. The next sort of thing that you need to look at is sort of modularity. So obviously, with a one solution fits all sort of scenario, there will be points where people may want, I don't know, the user aspect, so the authentication aspect of our library, but they may not necessarily want the asset upload aspect of our library. So you need to be able to create the library in a way that it can be sort of stripped down and be efficient so that people can use it on sort of multitude of different applications. And then obviously optimal performance, that sort of coincides with the modularity. It's making it as uncomplex as possible. There's no point reinventing the wheel. You want it to be like, if you want to update an image, it should be update image, and then it returns a callback giving you a Boolean value that is this successful, is this not, or it returns the address of the uploaded asset. there's no point in, making it multi-step, because at the end of the day, your job as the abstraction layer is to make those multiple steps into one easy to use function. So yeah, why use abstraction layers? So what we've just spoken about is hiding complexity, making sort of multi-step processes a one-step or a two-step sort of scenario, making really sort of complex callback scenarios into really simple, on asset upload, on asset update, meaning that when those things happen, you know what data you're going to be receiving. It's in a well-structured format so that you can access that data. Improving portability, improves portability, sorry. When you're writing your code, you want to use as little sort of third libraries as possible. You want to have sort of as much of it in-house. So that what I mean by that is, so for example, if you are writing like an XR abstraction layer, so XR encompasses sort of a multitude of different sort of scenarios. So you've got VR, you've got anything down to sort of robotics, you've got things like web, you've got sort of a multitude of different scenarios that could occur, and a multitude of architectures. So you may want to run your code on ARM processor, an x86, an M1 Apple chip, and all of these things need to be accountable when you're creating your abstraction layer, because the problem is as the world goes forwards, I mean, even for example with the Apple M1 chip, the Apple M1 chip is remarkably different, even though it has the same architecture, to the standard ARM chip that you would see on the likes of Raspberry Pi or Banana Pi or something like that. So you need to take that into account, and you need to, obviously you cannot necessarily plan for the future all the time, but you need to plan in a way that it's got that portability, that that there is an opportunity to be able to cross compile it on different platforms. Obviously you spoke about enabling modularity and flexibility. These are two things that are really important, making sure that it's flexible enough that it can be used in different scenarios, but then it also still holds like the core values of what you want your code to do. There's no point in making it in a way where people can kind of, pull bits from here, pull bits from there, because when you give people that opportunity, what you'll find is that you're always servicing products that aren't part of your sort of remit. And the problem is, when they're not part of your remit, you'll end up with a bloated code base that is really hard to service, because a lot of it is sort of nuanced cases. We're not looking for nuanced cases in an abstraction layer. We're looking for widespread functionality that can be used in multiple sort of aspects. So some well-known sort of what I would call abstraction layers. Obviously, abstraction layer is a thought process on top of a library. It's not necessarily anything different to a library. It still is a library, but the way that you utilize it is different. It's a system. It's how it sort of projects across sort of multiple areas. So you've got OpenCV. I'm sure sort of most of you know OpenCV. You've got CUDA, which is a graphical library, OpenGL, which is an open source graphical library, and then network protocols. So in the next sort of steps, I'm going to talk about sort of just a very high level on sort of what these are and how they've sort of changed the way people program through their use of abstraction. Before I go on to that, has anyone got any questions at all? No, nothing in the chat? Perfect.
I can't find any. If you have questions, by all means, post it in the chat and I will let Jack know.
Okay, perfect. So yeah, the first one's OpenCV. This is pretty much a night and day change for the programming community. It's written in C++ and it has sort of multiple languages, so Python, JavaScript. There is also some JS or third-party languages for it, and it allows people through sort of one or two processes to do quite complex vision-based algorithmic tasks. So, for example, when you receive MIPI data, which is MIPI is like a standard interface for camera technology, it comes through on a BGR format. So you need to switch that to RGB, which is what we naturally see, red, green, blue. So when you want to do that if you want to do that algorithmically, it's quite a lot of effort, it's quite a lot of code. You're looking, 100, 150 lines of code. to do that, efficiently, and to error check and make sure that what you're doing is right. With OpenTV, they've got it to a point now where you literally just call a function that's convert BGR to RGB, and you pass through your your mat class. And then obviously the mat class within itself is a very good understanding for people of how a well-defined objects within an abstraction layer can really sort of push forwards a project, because mat is now such a well-known sort of format in regards to computer vision. It means that actually other open source libraries can then adopt their sort of formatting, meaning that you can have sort of TensorFlow can you can pass through mat files into mat classes into TensorFlow or mat objects, which obviously makes it a lot easier for people that maybe want to try and use multiple libraries, but you already have that fundamental understanding because you already know it from your OpenTV. Right, so the next slide. So CUDA is it basically allows you to interact with an NVIDIA graphics card and do parallel processing. So that means you can pass through you can use their libraries which have got multiple functions in them. And what it basically does is it wraps their sort of machine code that they use to program the GPUs into something that's usable by sort of a lot of people. Don't get me wrong, it's still a very complex language, and it is a bit of a pain to use sometimes, and that's why people specialize in CUDA. But it's much better than it was. It's much better, and each iteration of CUDA, from like when I first started CUDA 8 and now we're on like CUDA whatever, it's really sort of come along leaps and bounds, and it just makes things super sort of simple. If you've got maybe some computer vision stuff you want to do, it means that rather than having to worry about, can my computer deal with this? Can it not? Like, you can just bang it on your graphics card and then throw it back in as and when it's done. Yeah. So the next one is OpenGL. OpenGL is really good because it's really good. Sorry. Oh,
it's fine.
Okay. So OpenGL is really good because it's cross-platform, it's open source. And it's used quite often for creating sort of graphical user interfaces. It's really low latency because of that, because you get to, you really get to sort of get down to the nitty gritty of, like what threads things are running. Yeah. So yeah, you've got the OpenGL, sorry, it's got sort of, multitude of libraries that mean that you can really sort of mess about with different parts of graphical user interfaces. You can also pass through map files as well, which means that you can render map files. Yeah, I don't know who this David A is, but it's, yeah. All right, so the network protocols. So network protocols is a really good, it's a really good sort of example of abstraction layers, because network protocols, we've all used them, HTTP, FTP, RDP for video transfer. They are all like a wrapper around sort of lower level code for transmitting data over the internet. And this is sort of really useful because it means that people can accelerate, when the World Wide Web was being created, people can accelerate their development because they have this sort of basic knowledge of like, this is how you send a HTTP request, rather than having to be like making sure you're checking the bytes, what size is your array buffer, can you pass it through, does it have to be a multi-part, transmission, are you even connected to the internet? This is all able to be done under network protocols. And then I've just created a simple example here, which is just a button class on OpenGL. So you can see here so the top one being the header, you've got these three variables. Then underneath that, you've got the sort of the implementation of these variables, and then you've got the normal code. So as you can tell, if I wasn't to create this class and create this sort of abstraction of what is actually going on, then this would start to blow up the system. very quickly, because maybe you want to have multiple buttons in there, buttons doing different things, etc., etc. Being able to create a higher level or sort of a library that means that people can use OpenGL at a higher level means that you don't have to worry about that bloat you can get from sort of standard development. At this point, does anyone have any sort of questions at all?
No,
Okay,
no, can't see anything.
Okay, so on this part, I'm just going to talk about some sort of basic sort of case studies as to when people may want to use abstraction with architecture and sort of software. So this is just sort of I'll skim over these because we kind of talked about this already. So with sort of architecture based, we have the classic of I want to utilize an FPGA, or this could even be a GPU with regards to CUDA knowledge. I want to use an FPGA, but our whole team is C++ based. So the main goal here of the abstraction layer is for familiarity, simplification, and teamwork. That means that the abstraction layer is familiar to the C++ developers. So the way they utilize it is similar, if not the same, to the way they utilize a standard C++ library. It's simple, meaning, as we talked about before, to implement certain features is not multiple steps. That upload picture is a single function, not multiple sort of functions that have to be called one after the other. And then teamwork, making the abstraction layer work in a way where sort of teams can collaborate with one another, because they're able to they're able to say you've got multi-client, they're able to talk to one another and they know what each other are talking about. Maybe one team has on update, but then one team has on picture update, and another team has picture update callback. But in essence, they both know what they're talking about because they're both sort of the same thing, but between different languages. This makes it, this is quite a cost-effective way of a company not having to, either pivot to FPGA development. It also means that they get to keep the same staff that they already have, and they're able to utilize, parallel processing and high bandwidth without having to worry too much about a really costly rewrite of their code. And then the next one, sort of software. So this is sort of what I do now. So with multi-client product abstraction, it's standardizing the interface, simplifying development, and reusability. So with what we do, a lot of it's about being able to rapidly sort of work in different languages. So for example, if we get a customer come to us, like a big customer, and they say like, we work in Python and we need you to create, well, we would like to use your library, but do you have a Python library? Because of the templating engine that we use on top of our C++ layer, we can then abstract that C++ into sort of Python or sort of anything else really, with very sort of minimal kickback from a sort of development point of view. Having that standardized interface means that like we can work with them without necessarily having to know the knowledge of that language, because we know what the underlying code's doing. And if they have any problems, any errors or anything, we can actually still assess what's going on without having to be a Python expert. Yeah, and this goes into sort of the simplifying development, making it super simple for them to use. They basically drag and drop it in, it runs straight away. It's not the case that they have to, install libraries that mean that they can run sort of C++ code on Python or anything like that. It's just very sort of simple for them. And then reusability, making things, work for more than one purpose. So for example, if you have a web page, there is no point having, if you have both web pages and profile pages, there is no point having a upload profile picture and upload image picture on an abstraction layer. That's a much higher level function. So you should always have, like, say, upload picture. So that means that they can upload the one picture and it's very sort of simple, reusable. That means if they want to create anything else, like they want to create groups or they want to create sort of something else that needs a picture uploaded to it, or albums, for example, they can just reuse that bit of code without having to come back and say, like, look, we need this added feature, because the feature's already there, because when we've used our thought process of the abstraction layer, we've thought, where is the best bang for our buck in regards to functionality? Because we're not looking for necessarily the best fix. We're looking for sort of a multitude of different things, best bang for buck in regards to functionality. Could it be reusable? Is it well defined? Is it understandable? And yeah, this is, so that's the sort of the software case study. And then, yeah, we'll go on to sort of some of my experiences. Sorry, 1 second. So the H3O project, which was a European Union funded project that I worked on, we created sort of some interfaces for them with regards to FPGA, some very sort of basic interfaces, meaning that they could use AI inference on Xilinx FPGAs. This allowed them to utilize being able to detect trees and the size of trees and do fruit counting with the added sort of power of the FPGA, but without necessarily having to have people that know about sort of FPGA development, which they found really useful, and it was really impactful because it meant that their guys could continue to develop doing what they needed to do, and then we could still be able to facilitate their needs at the same time. Right, and the next one. So this is, I'm sorry, I haven't been able to put all the names of the companies purely for NDA reasons. But I also worked with a company to do with camera and film. It was to do object tracking and object detection. So it was all to do with being able to follow certain, lines on the floor. So they did a lot of work with sort of the Premier League. So they wanted to be able to run their robot up and down the line, up and down the sideline. Then also with the added safety measure of using depth cameras to be able to stop the robot, say for example, if the linesman's in the way. So at the end of the day, their worst case scenario is if we go taking out the linesman midway through the game, and they've got to get, the reserve referee on. And yeah, so the next one was mapping mines. So this was an interesting one. So this was a really sort of useful use case in sort of abstraction layers. So they didn't know what sort of sensors they wanted to use when they implemented sort of this system. All they knew was that they wanted to use stuff like CAN's interface and a few other bits and bobs. So we created sort of an abstraction layer that meant that when they went down to the mines, they were able to sort of use multiple sensors without necessarily having to know what they were going to use beforehand. This is because obviously when you go down into the mine, there's no internet connection. There's, usually they're quite far away. I mean, I don't have a mine near where I am and I live in the Midlands. So yeah, they think this was all done down in Cornwall. So the abstraction layer was there to be able to create sort of simple functions that they could use to accelerate they could use to accelerate the features of their sensors on an FPGA. And yeah, so onto sort of what I do now as well, sort of multi-language abstraction. So Magnopus is known for being able to produce really high-end visual experiences for sort of multiple people, creating digital twins and a multitude of different applications. Whether that be on sort of VR headsets, on web, or sort of through games console development, so like Unreal. And one of the keys to this is the multi-language abstraction. We're able to very quickly implement sort of different languages, different sort of functionality across multiple clients, whereas you would have to, if you're using an agile process, you would have to create a ticket, and then that ticket would have to be spread out across all the clients. And then you have to make sure that they're all implementing it the same way so that they get the same functionality. Whereas what we're then able to do is we're able to be a single point of truth. So we are able to facilitate that. We're able to create the functionality, create the functions, and then when we use a templating engine to generate that to the multiple multiple clients, they're then able to use the same functionality. And it also works in a way that if there are any bugs, that they know where they come from. It's not a case of having to trace it down. It's a case of I've used upload picture, and upload picture has failed, I know that that comes from the abstraction layer. So that's sort of what I do with Magnopus at the moment. And then the last one is sort of the medical vision stuff. So when we were doing this was when I was doing this, I was the lead on this development. So it was to do with sort of creating a library that was, being able to be used by sort of R&D professionals within the medical field. Obviously, where they have sort of C++ knowledge, and they wanted to be able to utilize the FPGA, get functionality out of it, and pass things through from the DAM direct access memory, and sort of throw things in, pull things out, test different algorithms, etc. So my sort of role was to apply those algorithms to the FPGA so that they could utilize those algorithms in a parallel fashion and with high bandwidth. This was super cool because it was a different sort of issue every week. It was, we want to try this, we want to try this. Obviously, there's big lead times with medical because of the fact that it is, such a research-based sort of subject. So it was some, really good fun. Right. So just towards the end, there is it's not all, sunshine and rainbows with abstraction layers. There are a few sort of points where you shouldn't use them. So I'm just going to sort of quickly go over those. So when you've got critical performance, so if you've got, say for example, you're doing signal processing and you're trying to keep track of a sensor that runs at super high rate, so you don't have the time to be passing things to a CPU, running them through, or necessarily passing them things onto an operating system, for example. So there's no point creating more backlog by implementing the abstraction layer, because that performance decrease has no real benefit attached to it. So that is one of the sort of the normal reasons why an abstract layer may not be the best thing for it. The technology is simple. At the end of the day, there's no point reinventing the wheel. If it's going to be 50 lines or less in Arduino IDE or something, there's really no point in creating a library for it. And also, if customization is required, if you have if you have a company that has a multitude of different platforms that they run, so these being different software platforms, it's pointless you having a single abstraction layer that services them all, because it won't be well defined. And that being one of the key targets of an abstraction layer, you want to make sure that you are able to facilitate the key targets as much as you can, and all you will end up doing is having a really bloated code base that really doesn't serve its purpose very well. And so some examples we spoke about, so real-time processing, resource constraints. So for example, if you don't have the power because you're using an MCU, but you created your abstraction layer on x86 with 16 gigs of RAM, well, it's not going to work, sadly, because obviously you haven't got the ability to use the resources. You have energy efficiency, so maybe you're using sort of battery operated systems and stuff where you need to have as lower a much more lower level grasp of what's going on, so you can maybe track the battery usage. You're not running processes in the background that don't necessarily need to run. And also one of the big ones is cost effectiveness. If you are running something that your long-term goal is not to create sort of multiple products out of or service multiple clients, then it may not be necessarily cost effective to have an abstraction layer, because it really works best when you've got sort of a large scope of possibility in the future. And so that is pretty much everything. Thank you for watching, and you can keep up to date with me on jackpennell.dev or through LinkedIn at jackpennell.
Okay, thank you so much, Jack. I'm probably going to ask for you guys to post your questions on the chat, and I'll be reading for you all the questions that that people post on the chat. let's give a little bit more time. Perhaps I can start with the first question, Jack. So especially for people that are starting to get into DevOps, what are your advice? What should they start with? Imagine that they are fresh graduates. How should they start to engage with the DevOps community?
I think it's deciding what sort of DevOps you are. I think it's a bit like software development in general. Everything's different. You could be working for a bank or you could be working for a supermarket. You know, there's different avenues for everyone. For me, I didn't want to be the side of DevOps that is, you know, where it's sort of team city. It's creating sort of, you know, CI pipelines and that sort of thing, sort of development pipelines. I wanted to be doing some actual you know, some actual programming, but not necessarily it being client-based programming, which is sort of where my sort of obviously with the FPGA stuff, where my love for it came. And yeah, it's sort of manifested from there. I think it's also a case of when you get into somewhere, don't just take it at face value. See what you can get out of it, because you know, at the end of the day, when I joined DevSoc, I certainly didn't expect that I would be doing programming, you know, for a job afterwards, because I did a networking degree. I thought I'd be going in and, you know, working in data centers, etc. So you never know, you know, where life will take you, you know, if you're willing to sort of open the door, basically.
Okay. Any advice on which cloud they should start with, or any ideas, any suggestions?
I think, to be fair, AWS is sort of is the poster child for it. They've got everything. I mean, they've got FPGA based, you know, they've got FPGA based servers. They've got GPU based servers. They've got the ability to sort of spin up, spin down as and when you need to, and it's a very sort of competitive. It's a very competitive platform in regards to pricing. I think with a lot of companies, they worry because obviously from a sort of outward perspective, they don't see the value add of AWS services or cloud services in general, because you look at a server online and it's say £10,000 and they see that as like, oh, I only have to pay £10,000 and then I've got a server for life. Whereas, you know, if suddenly they become the next big thing, you know, their app becomes huge, then they need to scale up. They have no opportunity to scale up within their own premises, you know, whereas if they start off on AWS and they look at the, you know, sort of the options, it actually means that they get really good value add if they're looking to be a scalable company.
Yeah. You have been talking about, for example, the FPGAs. Any advice for people who want to start working with FPGAs? Imagine that you have finished your degree, for example, in computer science related. What is your biggest advice? And why do they care about FPGAs at all?
I think the main thing that I like about FPGAs is the bandwidth opportunity. You have the ability to add a lot of sensors, a lot of I/O to it, and it still be able to throw out really good sort of levels of performance, which you don't necessarily get with a GPU. You've got to sort of, you throw it in, and you know, as you put more and more intense on it, the frame rate gets lower and lower and lower, depending on what you're trying to compute on the GPU, which is something that will happen eventually with FPGAs, but there's a lot more bandwidth, which means when in regards to sort of robotics and stuff like that, where you do have sort of multiple motors connected to it, multiple sort of vision-based sensors and LiDARs, etc., it becomes really useful because it's one less headache. I think if I was starting off on FPGAs again, I think I would definitely, you know, make an effort to, like I said, you've got FPGAs at the university. I would really make an effort to, you know, speak to whoever's using them and see what they can do in regards to, you know, maybe spending some time with one. They're quite expensive to get into of your own accord because of just the price level of them. You know, a lot of them are space grade, scientific based products, so they're not necessarily things you can buy off the shelf. So yeah, I would definitely say speak to whoever you have at the university that, uses them and see whether you can get some time with them.
Okay, thank you very much. I'm still looking for some questions on the chat. I think people are very shy tonight, but I will definitely encourage everyone to ask some questions. There is also a form on the chat that I invite you guys to answer and tell us about what kind of talks you would like to have in the future. Again, as my colleague Bev mentioned before, if you are not member of the BCS and you want to join the BCS as a member, you can use this code, the BCS Nottingham 20. I'm going to ask, before going into the upcoming events, to everyone to clap hands for Jack. So there is a button that you can actually use to clap the hands, and it's very nice. And I can see already some people clapping hands. Okay, there's a question from Bev. Where do you see this technology going in the future?
At the moment, it's a bit up in the air at the moment. I think tech's taken a bit of a downturn in regards to sort of companies recently. I think with regards to Facebook and Meta, it's something that it's, how can I put it? I think they jumped the gun too soon. I think they jumped the gun too soon. I think if you'd have given them maybe another 3 or 4 years, I think they really would have been, in a good place with regards to the metaverse. I think companies like the one I'm working for at the moment have found like a nice sort of middle ground where their end goal is to create a metaverse, and they're working on sort of the standardized protocols for that. But actually at a lower level, they're still doing, the visual experiences, the different sort of, basically visual experiences within a wider audience, which is basically what's paying the bills, with an underlying, opportunity to do more. I think it's like with anything, is like if you look at you look at many sort of technologies that have come and gone, and you look at them back at them now, and you think they're actually pioneering, but at the time they didn't seem like they were. So I think metaverse is where it's going. I think that's where technology will be. I think with different sort of technologies like ChatGPT, etc., I think it will suddenly, the gradient will go like that, because there's a lot of how can I put it? There'll be a lot of code that's written very quickly because it's able to be written with AI.
Okay, thank you. I'd like to apologize because apparently there was some improper comments, and I'd like to apologize. I tried to remove them. Maria has just mentioned that she agrees with the remeta. Okay, so I'm going to use the opportunity to thank you again, Jack. It has been a very, very good talk to you tonight. Again, I'd like to encourage people to let us know what you think about today's session, but also to let us know what kind of talks you would like to see in the future. And thank you, and have a nice evening.
Cheers, guys.